Question asks, protonation at which carbon atom, 1 through 4, on the following diene will lead to the most stable intermediate? So this is part of an electrophilic addition reaction, and determining the most stable intermediate is really important for figuring out what the final product will be. So in order to do that, we have to do the first step of the reaction. So in this case, we have a diene starting material, and we have HBr as our key reagent. So if we're looking at our answer choices, peeking ahead a little bit, and thinking about what our choices are, we have carbons 1 through 4, and then E is this reaction does not involve protonation. So right away, I can cross off E because we definitely are going to have protonation since our starting material is a strong acid. All right. We can also think ahead a little bit and consider that our intermediate that is going to form will be more stable if there's resonance. So resonance stabilization is going to make for the most stable intermediates. So we can also cross off carbons 2 and 3 because if we protonate at site 2, we make an isolated carbocation with no resonance. And if we protonated at position 3, we would again make a isolated carbocation with no resonance. So right off the bat, we're down to carbon 1 or carbon 4 as our choices. In order to figure out which one is the correct choice, we have to draw out the possible carbocations and their resonance contributors. So let's go ahead and do that. I'm going to cross off the answer choices that I've deemed unfit here. And then let's first think about protonation at site number 1. So if we add a proton to that position right here, then we'll make a carbocation at that position. This is a tertiary carbocation. And let's draw the resonance contributor. The resonance contributor that we form is going to look like so, with a primary carbocation as the right-hand contributor. All right, so we have a tertiary carbocation and a primary carbocation. Next, let's take a look at a protonation site of carbon 4. So if we protonate at carbon 4, like so, we'll make this carbocation. And then if we draw the resonance contributor, we will have this molecule here. So we have a tertiary carbocation here. And when we draw the resonance contributor, we also have a tertiary carbocation here. And this is important because now we can really assess which carbocation is more stable. So if we take a look at this, it's pretty straightforward to see that protonation at site 4 will make for the more stable carbocation. So our 2 major products will come from the 2 resonance stabilized carbocations that are formed there. So the answer to this question is going to be D. Protonation at carbon 4 will lead to the most stable overall intermediate.